All right, for part B, we're gonna sort of like have a similar analysis, but it's a bit different from part A because we cannot immediately put this fraction in this form. Okay, so we have to sort of like work through that, and that requires partial fraction. Okay, we're gonna write that fraction in terms of the difference of two fractions. Okay, but to do that, we first have to find the right factors for 3x squared plus 5x minus 2. You can use the quadratic formula to find the zeros, and that would probably help you to construct the factors. But I'm going to write it right away, and then you can pause the video and you can sort of like work through that. All right, so we have x plus 2 and 3x minus 1 as a factor. So what I'm going to do here is that I'm going to look at the partial fraction here as a over x plus 2 and b over 3x plus 1. Okay, let's find a common denominator. So, all right, so let's rewrite this. So 3x minus 8, a times 3x minus 1 plus b times x plus 2. Okay. All right, so we're going to take sample values here. How about x equals minus 2? If x equals minus 2, minus 6 minus 14 on the left, b term is gone. Minus 7a equals negative 14, so that implies that a equals 2. Okay. If x equals 1/3, the a term is going to be gone this time. So this will be negative 7, 1/3, 7/3 b. So this implies that b equals 3. Okay. All right, that sounds good. So why don't we rewrite this partial fraction? All right, so we plugged in and be back in the partial fraction. So now going back to the original problem, I would like to put each fraction in this form. I want to write it as like a over 1 minus r. So I want to know exactly what a and r for each case. Okay, so thinking about this one, for example, let me just use a different color here. Okay, I'm going to do 2 over, so I should go with like 1 minus, right? I'm going to go with 1 minus, let's see, minus x. So, well, why don't we first like pull out 2 from the top and the bottom? I think that's going to make it easier. 2, 1 plus x over 2, right? So this way, these guys are divided out. So I can write this as 1 minus x over 2. I think that's easier that way. Okay. And let's see, 1 minus, okay, there's a typo here. Let me just put the 3 back here because this was 3x minus 1, right? I'm sorry for the typo. So this is 3x minus 1. Okay. All I'm going to do is to rewrite this as minus 3, 1 minus 3x. So in turn, what do we have? Let's sum them up, okay? So 1 over 1 minus x over 2. I have a minus sign here, so plus 3 over 1 minus 3x. Okay? Good, so I can sort of like get rid of this argument here. Okay, so I can get some space. Okay. And the very first fraction here, in terms of the geometric series, is written as like a times r to the n. There we go. And who is a again? Let's write that down too. A equals 1, r equals negative x over 2. So that implies that I have the sum starting from 0 to infinity minus x over 2 to the power of n. Okay, and for this one, a is going to be 3, and r is going to be 3x. Okay, so it's plus 3 times, I can pull the 3 out, it's a constant term, right? 3x to the power of n. So So essentially, this fraction is the sum of two power series. All right, and we can combine them into one. By the way, both sums start from the same lower limit for n and same upper limit for n. Okay, so I'm gonna sort of like rewrite this as 3 times 3x to the power of n. Okay, can we simplify this further? I think we can do that, right? Let's just work on that. So I'll just continue from here. So first of all, this is minus 1/2 times x to the power of n. So why don't we separate minus 1/2 part? Okay, and then I have 3 times 3 to the n x to the n. Okay, all right. Let me just go to the next slide. All right, I just copied that down here. So let's simplify this further. Well, this is negative 1/2 to the n, x to the n, plus 3 to the n plus 1, x to the n. Now x to the n is a common factor. That way we can write this sum here in terms of only one power series. Okay, so here we go. N starting from 0 to infinity. X to the n pulled out. I have minus 1/2 to the n plus 3 to do n plus 1 multiplying xn. Okay. All right, so now let's find the interval of convergence for this brand new power series. So to do that, let's go back and utilize the result for the geometric series. Remember that geometric series are convergent whenever the radius is 1, and we have 2 of them here. Right, we have 2 geometric series. Let me just clean this. We have 2 geometric series. One is this one. Okay, and the other one is this one. Okay, so for each of them, there's different r, obviously. So let me just do the analysis here. Okay, so for the first one, r is negative x over 2. I want that to be less than 1. Okay, maybe I should use another color here. How about that? Let me use red. Okay, here we go. Negative x over 2, absolute value is to be less than 1. And here, r is 3x, so I need 3x to be less than 1. Okay? And this one provides us, this one is providing us x over 2 in between 1 and negative 1, multiplying both sides by 2, negative 2x and 2. And then I have 3x in between 1 and negative 1 here, right? And dividing everything by 3, negative 1/3 x and 1/3. Okay, so we have to get the intersection of these intervals. We can't just rely on to just one of them, because let's say like if I take this one only, and then I know that this would serve for both of them because this interval is already contained in this one. Okay. However, if I take this one, well, let's say if I go with x equals negative 1, well, x equals negative 1 is not here, right? So this infinite series is going to diverge in that regard. So then I should get the intersection of those. And how do I do that? Well, we have the bigger interval, which is me putting 0 here, and negative 2 here, and 2 here. And then you have negative 1/3 and plus 1/3. So we have one interval here and another interval here, right? The intersection of that is going to be the one in the middle, obviously. So I'll take this to be the interval of convergence for the combined geometric series, which is the one corresponding to this fraction. Okay, so the answer for that question, to sum up, is negative 1/3 1/3. Okay, open interval. All right. Well, this ends the video. Thanks for watching. I'll see you in another video. Bye.